Okay, so I mentioned at the end of last term, I was debating about how to do this course, continue with our book or use some new materials like the CK12 stuff we're playing with. And I built 3 different versions and finally this morning decided to continue with what we've been doing, not throw any big changes. The only big changes are, not that big. I'm gonna do reading quizzes, which are pretty straightforward. Just it's very important you read the book because it's a slightly different perspective than the things I say in class. And so the reading quizzes are usually pretty simple. Like, what are the 5 main topics in this section? And you just say, hey, it's this, this, and this. Or what are the most important kinds of charts illustrated in this section? Things like that. So they're just quick, short answer quizzes that you'll take. And you'll want to do those before the homework. And then just like before, there's online homework. So for each section, there'll be a quick reading quiz and then the online homework. And then there'll be activities also. I had hoped to do activity 10.1 today, but since a couple of people are missing, I'm going to wait till Wednesday and hope everybody's here on Wednesday. We're going to do it anyway on Wednesday, but the more the people we have, the better it's going to turn out. And I posted a little note here. Those of us that aren't here, don't miss Wednesday because we're going to play with M&Ms. So, does anybody have an M&M preference? Everyone's going to get plain, but I can get other kinds too. Caramel, pretzel, peanut. Yeah. Peanut or peanut butter? Yeah. Which one? Peanut butter. Okay. Anything else?
I like them all.
You like them all? Okay. So we got.
I was in Safeway in the discount section.
Yeah.
They had peanut butter.
Okay, I will go check that out today. Yeah, so we'll have some plain ones so that everyone will have the same kind of M&Ms, but then we'll try some different varieties too, and we'll do a little statistics on M&Ms just for fun. So, and then in this area, I have some activities that aren't in the workbook. So in addition to doing some activities from the workbook, we'll have some activities that I'll provide. For example, there's the playing with movie data activity that you'll do maybe Wednesday, but probably Monday. And we're going to do a warm up with that with this right here. So wherever possible, I'll include that kind of stuff. For statistics, we're going to spend about 2 weeks on statistics, maybe a little bit more. We'll see how it goes. I'm going to try and get you to use a spreadsheet every day. So if you're not much of a spreadsheet user, we're going to try and ramp that up just a little bit more. And then the rest of the quarter will be spent on geometry, which is one of my favorite topics. So, and then on days you can't come or you miss a class, there's the link, same link as the previous one. Let's see, my recent playlist in YouTube, an older playlist in YouTube. And then if you want to connect live, there's a link there to get to the live link, which I remember to post most of the time, but not all the time. So my apologies if I forget. Okay, so let's do some math. The main topic for the beginning of the course is statistics. Letters. And this is chapter 10 in the book. And hopefully, we'll go to the lab in just a little bit so everyone can get on a computer. But if for some reason the new version of the course, if the links to the book aren't working, we still have the old version of the course. Everybody know how to get to the old courses in Canvas? So I'll show you that quick, just in case that comes up today, because there's reading you need to start right away today. So if you go to your courses button on the side, there's an all courses link on the bottom. And then it'll be broken up into current courses and past enrollments. And you can always sort by term if you have a lot of them. You guys probably don't have as many as me. Or you can search for something like MTH 212 and it'll pop up the course there and then you can get back into it.
Maybe this is just my something, but I did something and I got to my last course and it would not.
Okay, so that depends on a couple of things. A teacher can have the course only available for that quarter. I try to leave my courses so they're always open for you to grab as long as you have an account here. So it depends on the course. Was it my course or someone else's? It was my course you couldn't get into. Oh shit.
I'll try to get, when we go into lab, I'll try.
Yeah, because I looked at the settings right before class and I thought I had it set you so you could still get in.
I got to it a little different. I wasn't in. But
Okay.
I'll try that way.
Okay, so yeah, we'll double check when we're in the lab, make sure everybody can get to something in there. All right, let's go back to class. All right. So first thing we're going to do is just, if you write down 5 words that come into your head when you hear statistics. What other words pop into your head when you hear the word statistics?
Sounds kind of terrifying.
What's that?
It sounds kind of scary.
Just write down 5 things.
Okay.
It's 5 words. I'm not asking you to define statistics yet. I'm just saying 5 words that come to mind when you hear statistics. Get as far as 4 words, we call that cool. All right, so give me some words.
Sports.
What's that?
Sports.
Sports, oh yeah, lots of statistics are in sports. What else?
Percentage.
Percentage.
I thought of like a business presentation.
Business presentation. What else?
Data.
Data. Crime. Crime. It's funny, the word that popped into my head right after crime was politics. I'm always excited when there's an election going on because there's all kinds of great statistics that come out. I get to have a lot of fun with it. Other words.
Graphs.
Graphs. Definitely. And I've had a similar word in mind. I was thinking charts. Kind of the same thing. Come on, Sydney, help us out here. Give us a word.
I have pretty much all of those.
You have all those?
Yeah.
Anything that's not up there?
No.
Okay, that's all right.
I didn't even have one.
You come on. You didn't have
I'll
fun.
think myself. And then I'm like,
Just gonna write anything down. I mean, okay, so you know the first word I came up with? Eyes. There's a lot about lying with statistics. Surveys, it's a word that came to mind. Numbers.
I said numbers and I was like, that's stupid.
I mean,
That was the first thing.
we do statistics with numbers. Is that the only thing we do statistics with? Can you give me an example of statistics without numbers? We'll get there. Okay, so just brainstorming, loosen up our minds, think about the topic a little bit. So some big words. So I'm just going to do a lot of vocabulary right now, and it's going to be kind of boring, but try to incorporate you as much as I can. When we're talking about statistics, some big ideas are an idea of a population. What population is being referenced with those statistics? Okay, so a population could be something like, so some examples, Oregon residents. Could be something like female college students. Think of any other populations of interest that might come up in the statistics. Elementary school teachers. Humans. Sometimes when we talk about statistics, it's statistics related to all humans. Huh, I think you have statistics on all humans. So with regards to population, there's another important idea called a sample. And a sample is just part of some population. So whenever we work with statistics, there's got to be a target population. Maybe it's all BMCC students. Maybe it's all college female students. Maybe it's all Oregon residents. Maybe it's just the people in the room today. Then you have a sample, and that's just part of that population. When we are working with a population, certain special numbers related to that population are called parameters. So an example of a parameter would be the average, say, height of a male. So if we considered all the males on the earth today, there is an average height to all of those males. Can we say what it is? Probably not. But we can try and find it by using samples. When we're working with samples, and we have some special number, that number is called a statistic. So we have samples, statistics, we have populations, and parameters. And the point of this connection right here is that we use these sample statistics to estimate population parameters. So any interesting population, it's pretty much impossible to get all of the data for it, okay? Unless it's just something like students in Math 213 at BMCC in spring of 2018, right? Then we can definitely grab that whole population. But for most situations, it's not possible to grab all the people, right? Think about, let's scale it down. I'll scale it up a little from this class and just say, there's gonna be an election soon in Pendleton for city council. Are there a lot of people in Pendleton? Well, it depends on what you mean by a lot, right? Compared to Ione, yeah. Compared to Portland, none, right? Then we narrow down from the population of Pendleton to the eligible voters in Pendleton. And then from there, the people who are actually going to vote. So whoever's running for city council cares about which population. All of Pendleton, the eligible voters are the people who are actually going to vote. The people that are actually going to vote, right? That's their really interesting population. Now, they may be interested in the eligible voters because perhaps somehow they have a message that's going to get one of those eligible voters that wouldn't vote to actually vote. Okay, so maybe they might get a little more ambitious and go for eligible voters, right? So those are 3 different examples of populations. They're not quite the same, but they're related to each other. Do you think it would be easy for us to get a hold of every eligible voter in Pendleton? Not really. I mean, we could go down to the city hall and they could give us a list of the eligible voters, but then what? We got to communicate with them somehow? That's no small task, even for a small town like Pendleton, right? So the reason we have statistics, which is stuff we do with samples, is because for most reasonable examples, the population is unattainable. We just can't get to everybody. Can you think of any situations where we try as a group really hard to get information from everybody? Census, yeah. When a sample actually consists of the whole population, then it's called a census. So the idea of a census is to get the entire population. So census gets the entire population. And how often do we do a census in the US right now?
10.
Every 10 years we do a census, and it's a huge undertaking. We try really hard to get to everybody. We get most people, we don't get everybody. But it's an attempt to get everybody is what a census is. And the US does that a lot, and they have an awesome website with tons of data. All right, so I got an extra letter up there. All right. So bottom line, though, is a census for most examples is pretty undoable. It's not within most groups' resources, so we have to settle on samples. And when you do a sample, there's a couple things to consider. One is variability in samples. And 2 is sampling methods. We'll talk a little about variability in samples and sampling methods. So first, we'll start talking about sampling methods, and then we'll incorporate the variability stuff into that. Do me a favor, everybody check right now if you have any change in your pockets. Or if you have pockets at all. Emily's not moving, she must not have pockets. Any change in my pockets today? Nobody? Either no pockets or no change? Okay, so suppose I was interested in how much change people carry on them, and maybe I was focusing specifically on their pockets, like I just did. What did our sample give us here? It gave us 0. Or did it give us nothing? Is there a difference between 0 and nothing? Come back to that. I just did a sample, it was called a convenience sample. You guys were right in front of me. I didn't have to do any work but say, hey, you got any change in your pockets? Super easy to do. Do you guys like math? Raise your hand if you kind of sort of like math. Oh, good. So I can post a news article that says 3 out of 5 students at BMCC think math is sort of kind of cool. It's a valid statistic. You guys are my source. There are 5 people here. 3 out of 5 kind of raise their hands. Right, so convenience samples can be dangerous. They can be misleading. But we do them all the time. Okay. But it's just one kind of sample. And they're pretty common, unfortunately. Ideally, we're hoping for some kind of random sample. So in 211, we talked about the idea of a number. And from number, we talked about the idea of numerals. We write them down. And in order to write numerals, we need digits. How many digits does our number system have? 10 digits. Okay, so you guys are going to be random digit generators. Please write down 5 random digits right now. Fast. Don't even think about it, Taylor. Just write them down. There's mine. Taylor, what will be yours?
1, 4, 2, 3, 9.
All right, Sydney.
2, 1, 3, 5, 6.
Ashley.
2, 7, 3, 2, 1.
Tiffany.
8, 3, 2, 1, 9.
Emily.
6, 5, 9, 7, 4.
Interesting. No zeros. It's like one of the most special digits of all. So did anybody have a hard time being random? Yeah, what the heck does it mean to be random? We talked about this a little bit last term, right? Flipping a coin. We expect the coin to be fair, and so we randomly get a head or a tail, not knowing what we're going to get at any time. And so we're trying to write numbers, not knowing what the next number we're going to write is. Could that be a random sequence of digits? Like, could you get 5 heads in a row? Yeah. It's less likely we get 5 ones in a row because there's more options, right, than a head or a tail, but it's a possible outcome. All right, so random sample. There are different kinds of random samples, though. There's one that's called a simple random sample. There are what are called systematic random samples. There are clustered random samples. Here we go. There are grouped random samples. And there's a whole bunch of others I'm not thinking of at the moment, and probably some I've never heard of, for sure. And there's reasons why we'd want to do one or another. So I'm just going to talk about those 4 types of random samples, and then we'll get to move on a little bit. So a simple random sample each group of size, that size n has an equal chance of selection. So say I was interested in BMCC students, and I was looking at groups of size 5. You are one possible group of size 5. But there's a whole bunch of other groups of size 5, of which some of you would be in. So just imagine thinking about all BMCC students in all possible groups of 5. Each one of those groups of 5 should have the same chance of being selected as any other group of 5. So if I just walk into this room because I like it and pick U5, that wouldn't be a simple random sample because you guys are here for a reason. There was nothing random in me walking in this room. I happen to have an office right next to it and you guys happen to be in my class, right? This is what we call the convenient sample. But if it was done in a way that this group of 5 has the same chance of being picked as any other group, then that would be cool. So we talked about probability, and the n is whatever the group size is. Maybe we're doing samples of size 20. Maybe it's size 100. Maybe it's 1,000. We need 1,000 people for a sample. Okay. There's ways to estimate how big your sample should be to get a certain reasonableness in results. We don't have time to get into that. You get to that in the first or second course in statistics. But back, a little review of some of the probability stuff we did before. Let's suppose our n was going to be equal to 5. So I want a group of 5 people in my sample. And let's suppose we're talking about BMCC students. And just to make this a little simpler, I'm going to say that there's 100 BMCC students. In any term, there's more like 2,000 or 3,000. So the question I have is, how many groups of 5 are there based on that 100 students? Okay. So I need to build a group. How many students do I have to choose from for my first member of this group? 100. There's 100 possible students I pick. So I pick, and Taylor gets randomly picked as my first student. Then I get to pick a second student. How many students are left to pick? 9. And then for the third slot for my group, 98. Right, we did this before with other kinds of problems. 97. And then 96 for the next one. So there's 1, 2, 3, 4, 5. If I multiply those 5 numbers together, that'll tell me how many possible different groups of 5 can be made from those 100 people. Just to get the idea of probability with randomness. So whip out a calculator. What is 100 times 99, 98, 97, 96, 2, 3, 4, 5. Ooh, that's a big number. Need some commas. 1, 2, 3. 1, 2, 3. There's 9 million groups of 5 you can make out of 100 people. That's a lot. So what's the probability of this group of 5 students being picked, given that there's only 100 students? 1 out of 9 million. Okay, so I just want to, so probability has something to do with randomness. Every group should have the same chance of being picked. Okay, now think about my convenience sample. You guys are convenient to me, right? Okay. How many students are at BMCC really? Well, this quarter is probably more like 2,500. So did you guys really have a 1 in, so it's going to be way more than 9 million, right? Do you think you had a 1 in 9 million chance of being picked by me to answer the question about the change? No, you were totally convenient. You had a 100% chance of being picked by me because you were there when I thought of it. Right? So just another reason convenient samples are dangerous. They kind of have very little to do with the probability. We take a huge chunk of the population, kind of throw it away, and say, we're only going to look at this smaller group. But when we talk about randomness has something to do with probability. So I thought it was good to review that. And I lost my magic pen.
It's under your keyboard.
Ah, thank you. All right. So that's the idea of a simple random sample with a little bit more detail. Some other random samples are the idea of a systematic random sample. And in a systematic random sample, usually what you want to have is you want to have some kind of list. And then from that list, you need a starting point. So for example, I'm going to start with the 7th person on the list. And then after the starting point, you need some kind of interval to choose the next person or thing. And so example, I'm going to grab the 20th person after that. So in my list of people, I grab the 7th person, the 20 people later would be the 27th person, 20 people later would be the 47th person, and so on, 67th, until I run out of people to grab. So this, and so the key here is that I randomly decide on which person to start with, and then I randomly decide how far to jump to get to the next person, but then I hold on to that. So this is a way to generate a random list of people from a given population. Okay. What's the downside to this approach? Well, I have to have that list of people. So this could be going down, if we're talking about eligible voters, going down to the county courthouse and getting all the eligible voters for Pendleton. I have to get that list. Once I have the list, I can't possibly talk to all of them. Maybe I only want to talk to 100 of them. So I would grab the 7th person and every 20th person until I got 100 people, and then I go from there. So that's one way to generate a random sample. Does this, do you think, lead to a simple random sample? That idea I expressed earlier, that every group of size n has the same chance of being selected as any other group of size n. You think I've satisfied that idea there? What's your intuition say? Question is, with the way I described a systematic random sample, is it also a simple random sample? And the answer is yeah, it is. It's a simple random sample. Again, provided that I randomly decide on a starting point and randomly decide on the interval to jump to get to the next one. So other kinds of random samples, clustered, and then grouped. So with a clustered random sample, what you do is you take the population and you break it into subsets. Those subsets are called your clusters. So maybe they're neighborhoods in Pendleton or in some city. And then once you have those clusters, those subsets made, then what you do is you randomly select some of the clusters. Once I do that, I have to sample everybody in each cluster. So an example of a clustered sample that happens at the college almost every year, the state or federal government, since we get money from them, asks us to survey students occasionally. And the way they do that is they say, randomly select 20 classes. And then each student in those classes has to fill out this survey. And so then somebody has to come to the room and make sure every student on the roster eventually fills out that survey. But only those 20 classes. And for some reason, my classes get selected like every year it happens, which is always a bummer because I lose a damn class. But it's an important thing and it's a way to try and get a random sample. That wouldn't be a simple random sample. It's a little more complicated. Each group of, say, 20 doesn't have the same chance of being selected. But that's one way to, another way to do a kind of random sample. A grouped random sample is a little bit different. With the grouped random sample, there's a definite reason for the groups. So some examples of reasons we might have for the groups. It could be male versus female. It could be age, like teens, 20-somethings, 30-somethings, and so on. And with a grouped sample, what we want to do is get a certain percentage from each group. And usually we want the percentage of the group in the sample to match the percentage in the population. And that means we have to know something about the population ahead of time. So the difference between group and clustered, we're making subsets of the population in both of them. In one, we just grab a couple of subsets and we forget about the rest. But we have to get everybody in those subsets for information. With the grouped, we make these subsets and we get a certain percentage from each and every subset. So maybe a population is half male, half female. When we're done with the survey, our sample better have half female and half male. Suppose we grabbed randomly 20 people out of the population of the eligible voters in Pendleton. Is it possible that all 20 randomly selected were men? Yeah, and that might be a problem. We might need female opinions too, in which case we wouldn't want to do a simple random sample, we'd want to do a group random sample, because we need male and female opinions. Maybe we need female opinions from 20-somethings, 30-somethings up to retired age. And we want to get a certain percentage of each of those. So there are reasons why we might not want to do a simple random sample. Could be due to geographical concerns. It could just be to get a thorough view of what the population thinks. But there's tons of other ways to get samples. I just wanted to show you a few of them. All right, next topic related to samples is the idea of variability. Since you guys are on the verge of falling asleep, we'll pause after this and do some actual statistics. So any sample I get is going to be different than another sample that somebody gets. Okay? So just imagine having that list of all eligible voters in Pendleton. We put it in a spreadsheet. We tell the spreadsheet to randomly select 20 people out of that list. And then the next day we tell them to randomly select another group of 20 out of that list. Each group is going to be different, agreed? So what kinds of things do you think are going to go into the variability in samples? What's that?
How big your,
The size of the, yeah, size, okay, so that's a good one. So population size and sample size. They're going to have something to do with it. What else do you think might be relevant to variability?
How you're choosing the position?
Yeah, the method is going to have some variability. Yeah, so size is going to have something to do with it. The method for your sampling will have something to do with it. And there's just going to be some natural variability. It just happens. Like I mentioned earlier, it's possible that we'll get a group of 20 guys when we reach in and grab a random group of people. It's possible another time we grab 20 women. And so that can happen also. So those are pretty much the big ones on variability. But the bottom line is every single sample is going to be different. And we've learned a lot over the years of doing sampling. And in a lot of instances, it turns out it's better to do a bunch of small samples than to do one big one. Turns out you get slightly better information when you repeat that sampling process a few times. All right, that was getting kind of boring. There is a lot of terminology, and so I'm going to ask again that you read through the textbook Today we're going to cover section 10.1 and 10.2. 10.1 is about sampling and the basic idea of statistics on samples, and 10.2 is about graphical display of the data. So we're going to start doing some graphical displays. So I'm going to stop this video here. Hey, Nikki, I see you're online there. I'm going to, in a few minutes, I'll restart a new video because we're going to move into the computer lab so everybody's on a computer. And I'm going to have you guys fill out a survey, and then we're going to play around with the data in that survey. We're going to get to talk about the different kinds of data we can collect. Like earlier I mentioned, can we do statistics on things that aren't numbers? And the answer is yes, we can. Right? And we just talked about one a little bit. I talked about the idea of male versus female. That's not a number, but it's definitely a thing we might be interested in when we're collecting information. Right? Was the person that gave the information male or female? You think of some other things that might come up when doing sampling that isn't a number. You guys are on fire today. Wednesday will be better. We'll have lots of sugar. You can't get out of the number mindset.
Yeah.
So okay, so just some trivial things. Eye color. Right? It's not a number, it's a quality of something. I mentioned politics earlier. When an election year is going, I'm always interested in the kinds of information that's being collected, and political party is one. Democrat, Republican, Independent, Green, whatever. You mentioned sports, the team that somebody's on, the position that they play. Those are all pieces of information that are collected that we could then do something with. So you guys come up with anything else based on those? Okay, this is a good place to pause. So Nikki, I will in Google Hangouts, I'll post again a link to the next recording. It's going to take me about 5 or 10 minutes to make that happen. Okay. And that's it. So I'm going to pause this here, and then we'll restart in the computer lab. So take a break. I'll see y'all soon.